Okay, the last video we did was on the fade of the LED. It was our first introduction to pulse width modulation. This is really going to be kind of a continuation of that. We're going to go right back to that fade circuit, but this time we're going to add an element in that lets us manually adjust the brightness of the LED. Instead of having the computer always use the same rate of increase and decrease, we're going to pull that out of the code and give that control back to a human, turning a knob. So you can set the brightness and leave it at any brightness that you want. Now, this might come in handy someplace like if you take your building and put it on display somewhere, and the room lighting is different, and so maybe the lights are too bright, or maybe they're not bright enough. You could reach in and spin this little knob and adjust the brightness. So let's see how we can do that. We're going to go right back to where we were on the fade circuit. Remember, we had analog pin 6 hooked up to the LED, and we were controlling it with code, this simple code right here, and we had two fixed loops, right, where we were running around, counting it up to 255, dropping out, counting it down from 255 down to 0, coming back up, resetting it, dropping it back out. But we had no control. It was a fixed blink rate. The only way to adjust that was for us to go in like I did and play with that delay time. And we couldn't stop it. We couldn't freeze it anywhere. It was a constant fade in, fade out. So let's make it a little bit more practical. We'll scroll on down that page here, and this is how we're going to do it. We're going to add what's called a potentiometer. That's a variable resistor. It has 3 leads. One lead hooks to ground. One lead hooks to the positive 5-volt supply. The third lead is the variable voltage level. As the wiper moves across internally on that movable wiper arm on that resistor, it actually is changing the value of the resistor, and thus it's changing the value of the voltage being developed across that resistor. And we take that varying voltage value and we bring it in on what's called an analog in pin. In our case, we're going to use analog 0. This is what it looks like on our breadboard. Okay, we have a digital input pin 6 over here. We're still on 6, coming over to our resistor to our LED. So you can say that's the output circuit. Okay, that's where we do our pulse width modulation on the output to control the brightness on that LED. But now we have what we call an input circuit. So here's our variable potentiometer, and it has the 3 wires to it, 1, 2, and 3. Okay, the orange wires coming down, going to our 5-volt supply. The black wire comes down and goes to our, well, doesn't go to the board, goes over to our ground bus, and we share it with that blue wire, which is coming back to ground. So we have our ground and we have our power across that resistor. And then the wiper arm is the yellow wire. Now, on this layout, I didn't have room to get that third wire in on this side, so I just moved it around to the back side and plugged it in on the middle connection. So that comes around, and here you can see our analog in circuits. Okay, so I plugged that into analog 0, and that's all there is to the hardware. So let's see what we can do with that in code. And again, I'll kill that background so it's not so bright. You can see the code a little better. Now, we declare a couple things to get started. Okay, we said LED pin is still 6. The pot pin, this is the new one. We're going to use analog pin 0. Okay, so we say we want to use A0. It tells it we're using the analog, and if you don't put the A, it's going to assume it's a digital. So you have to put the A to make sure that it knows that you want to use it as an analog address. Okay, you set an integer called output. You declare an integer called output. You declare an integer called LED value. You drop into your setup loop and you go into pin mode. And again, as you've seen in the past, pin 6 gets set to an output. That's the pin that our LED is attached to. We drop into our loop. Here's the bottom of our loop, the top of our loop. So we're going to repeat this code over and over again, right? And the comment says read from potentiometer. So output, which we declared up here to be an integer, okay, we do an analog read of pot pin, which is analog pin 0, right? So we're going to find out what the voltage level is on that pin. The next thing we're going to do, the comment says we do a mapping of the values between 0 and 255 because we can give output from 0 to 255 using the analog write function. Remember just a minute ago in the fade, I told you the legal values for an analog for a pulse width modulation was 0 to 255. Well, an analog input is scaled differently. When you read an analog input, it has legal values from 0 to 1023. And of course, those numbers are going to, once we get past 255, that number would be an illegal value out of range, and our pulse width modulator output would see no difference. It would already be at full brightness. So we scale this with a function we call map. So we say map, we want you to take the value and output, and we want you to scale it from 0 to 1023. We want you to represent that as 0 to 255. So now output is remapped for us. LED value is mapped for us between 0 and 255. So we take that LED value then, and we do an analog write, just like we've done on all the others, to pin 6, and we say set that pulse width modulator to the value that's currently in LED value. And then we delay 1 millisecond, and we repeat. Okay, and we just go through that over and over and over again. Now, if we don't touch the pot, LED value is not going to change, right? So we're going to constantly be writing that same value out to the LED. Thus, we freeze it in time, and we can hold any value we want. So let's take a look at that on our video and see how that looks on our video. Let's play that. I'll skip forward a little bit. That's me rolling around on the chair. I'm putting my screwdriver in there to try to keep my hands out of the way. And you can see I'm adjusting the brightness of that LED. It comes up to full brightness, and then I begin to dim it back down again. And of course I can freeze that anywhere I wanted, so I could adjust the brightness and leave it at a set value. Let's see how that looks on the real camera, on the live camera. Once again, you probably hear me rolling around in my chair. Give me a second to get my screwdriver in the slot. Hard to do with glasses in the dark. Now here I am. That's live. You can see me adjusting that live. Completely out. Let's see if I can just barely on. Okay. And bring it on up. But see, if I take my screwdriver out, it stays there. It'll stay at that value now until, of course, I go in and change it again. Fair enough? Quick little adjustment, but it's something to show you the flexibility of code. I used the same LED circuit, but I just added an input, and I was able to, with 3 wires, I was able to change the behavior of that LED. Let's let that soak in, get ready for the next video. Have a good day, guys. Catch you later.